Now I'm going to talk about document search, which I think Vaidi alluded to. It's like looking for a needle in a haystack. So what's the problem with document search? What does that really mean? Well, the problem is basically to find the most relevant documents to a query or a question from a very large corpus of documents. So say your corpus is Wikipedia, and the goal is basically to say, okay, given any question that could reasonably be answered by Wikipedia, by any document in Wikipedia or any passage of Wikipedia, find that specific passage and return it to the user. This is actually the backbone of fields as varied as product search, automated customer support, and ed tech. Something like product search, you might be searching reviews and wanting to answer questions about wanting to answer questions about a product. Or you might be searching for a product and want to search all the descriptions of different products to find the most relevant products. For automated customer support, a customer might be asking a question and you want to search a very wide bank of frequently asked questions and their responses to give a good answer. And for something like ed tech, you might have a textbook and you want to search, given a question, you want to return the part of the textbook that answers that question. And so you can see that document search is really widely used in computer science. It's a very fundamental problem, basically information retrieval. And most people still use lexical search, things like Apache Lucene or Elasticsearch. And that works, but in the last 10 or so years, people have found that semantic search can perform more than twice as well. But the problem is that semantic search can be very slow on a CPU. So most people still use lexical search because semantic search, is very difficult to put into production, and it can take even a few seconds to do a query. And really, you want to return responses to user queries in less than 100 milliseconds or so, or a couple hundred milliseconds. So enter ThirdAI document search, which is powered by our MaxFlash engine. And so sparsity allows us to avoid billions of vector multiplications that take so long for each query. So we still get very fast speed, like Elasticsearch or lexical search level speed, while still achieving the accuracy, more than 2 times accuracy of lexical methods. So twice, would basically get the speed of lexical methods and the accuracy of semantic methods. Okay, so let's jump into an example here. I'm just going to do some imports, and now I'm going to load an index that's been pre-built with the MS Marco passage ranking data set. So I'll just run this because it takes a minute or so to load it, and then let me explain what MS Marco is and why you should care. So MS Marco is basically a data set that has 8.8 million passages from all across the Bing search engine. So basically, Microsoft curated this data set that has that had the most common that had basically a bunch of different top return passages. And then the goal is basically to say, okay, given a query, find the most relevant passages from that huge index. And this is actually a benchmark for most information retrieval algorithms, and there's a whole leaderboard. So when I say that we achieve state-of-the-art accuracy, that's as compared to all other methods on that leaderboard. And so, here I say we achieve MR at 10, which is, kind of like a recall metric of how often you achieve. It's how often you retrieve the top result in the first 10 of we achieve of 0.38, which is pretty much state of the art. And like I said, this is about twice the lexical method. Lexical methods usually get around 0.17 to 0.2% MRR. Okay, so now let's just run the demo. So here we can see, I just want to say it's very easy. We just deserialize the index from file. We've already pre-saved it. We also loaded an embedding model. And now I'm just going to run a nice little interactive demo where, so you can see what the demo is doing is we'll read the query, embed it, and then query the index with it. Okay, so let's just ask some. So MS Marco, like I said, has a bunch of general knowledge passages. So let's just ask some general knowledge questions, like when was flight invented? Okay, and you can see it says we got a pretty good answer. The history of the airplane shows it was invented by Orville and Wilbur Wright. They got the patent 9 months prior to the flight, December 1903. So you can see here that there's no real, like, a lexical method might not, this says the history of the airplane. It's something really that directly says, oh, like when was flight invented, all close together, that a lexical method might need. This is very semantic, like this is the meaning. We're going for the meaning. Let's try a different one, like how does a car drive? Here we say the powertrain provides power to the car, power to my bench. So that you see this is, again, exactly how a car drives. And there's nothing here that's really a direct lexical match. We can say, for like, how much is a shipping container? A shipping container you can expect to pay around $3,200 new and between $1,400 to $2,000 used. So you can see, again, there's nothing really here. There's no word much here. It's kind of like you need to know that how much the shipping container is asking for the cost of a shipping container, and then you need to know that this response is talking about how much a shipping container costs. So you see, you need some sort of meaning here. Okay, but what if we want to add something new? If I search what is ThirdAI, it doesn't give us anything about the company because this is a general knowledge data set that was made a few years ago. So let's add something new to our index. Oh, whoops, I also forgot to end this little demo. Let's add something new. We're just going to add the first ThirdAI webinar. And then if we run this again and we say, when was the first ThirdAI webinar, we get this result. So that's great. That's awesome. But what if we want to build an index from scratch? This general knowledge index is not always so useful. So here I'm going to load an index that I've pre-curated data set that consists of all the Wikipedia articles that are about deep learning. And so we have about 800 or 1,000 passages or so that we're going to add to the index, and you'll see it'll take about a minute or so. And yeah, basically the key thing here is that for every document and for every text, we're going to embed it and then add the document. Okay, so this will take a little bit and then we'll query it. And so the idea here is that if you have specific, like domain specific, document search or question answering problems, you can just easily build an index with this Max Flash engine and then query it, achieving state-of-the-art semantic results with a very fast and very quick amount of time. So here we say, okay, well, let's ask some questions like, what is the difference between supervised and unsupervised learning? And also, by the way, it'll catch spelling mistakes because these are embeddings, and it's just spelling mistakes will map to about the same embedding. Okay, so unsupervised learning, no labels are given to the learning algorithm, leaving it all on its own defined structure in the inputs. Whereas, let's see, and unsupervised methods cannot be used. So, we're getting information about supervised and unsupervised learning here, and the differences between them. We also might look up, machine learning issues and flaws, right? And we see, although machine learning is informed in some fields, it's often failed to deliver effective results. Reasons are numerous: lack of data, lack of access to data bias, privacy problems. And we also get this interesting thing about adversarial machine learning, which is ways that when people come up with, bad examples to try to fool machine learning models. We also might look up who are the most important people in machine learning, right? And we see, okay, cool, we get a very interesting list of people that are influential in machine learning. And the key thing here is like this list of people, right, does not obviously have a lexical match. All these things don't have obvious lexical matches to the queries. We're really searching based off of meaning. And with that, that's the end of my demo here. Whoops, I meant to press quit. And yeah, I'll give it over to Vaidi to finish up.